So in this video, I want to talk a little bit about the Digikey website and finding parts on Digikey as I'm moving deeper into designing my own boards in KiCad. Finding the actual device to drop into the schematic and the footprint becomes even more important. And although KiCad has a really deep set of devices and footprints, often I don't find what I need. I've been using Digikey here for quite some time. I'm somewhat familiar with how to search things on it. It takes a bit of time to figure out how things are organized. You can do the same thing in Mouser or other sites. Just Digikey's become my go-to here, and it's who I use. So I'm going to kind of talk about, say, Digikey here and finding stuff we need. So I know I need a USB-A type connector. It needs to mount to a printed circuit board, and I want it to be right angle so that it's off the edge of the board. So let's see what we can find. So I'm just going to start by searching USB. That just seems like a good place to start. And I immediately find USB, DVI, HDMI connectors. So that seems really promising. I don't need a cable. I don't need an adapter. This seems like the right group to drill down into. And immediately we get a huge number of hits here. 3,594 hits. That's a lot of stuff. So let's see if we can start to filter this down. DVI-A might be a good filter here. Actually, no, DVI, what am I saying? I want USB. So USB, there's micros. I want a USB-A connector. So, there it is. So let's go ahead and select it, and we need to apply. It tells us there'll be 808 devices remaining if we apply the filter. Let's go ahead and apply it. And it looks like we're getting close to what we want. Actually, this looks really good. But let's go ahead and play with the filters further and see if we can drill down even more into this. So in my case, how it mounts to the printed circuit board matters. Oh, excuse me. There's a lot of options here. Bulkhead doesn't seem to make sense. Flange doesn't. Okay, so this really isn't helping me here. Let's look at the actual mounting type. Board cutout. Cutout means there's going to be a hole cut in the board for it to sit inside of. Board edge, maybe. Surface mount, through hole right angle. That sounds like what I'm after right there. Is it's going to sit on the edge of the board? No, it's got a cutout. I don't want a cutout. So let's keep drilling here. It's not surface mount. There we go. No, it's panel mount again. Through hole right angle, maybe. It kind of becomes, try and search is okay. This is looking very much like what I want. And you'll notice here that this part's been seen before, and that's actually the part I'm after. But again, we could keep playing with the various filters here to get what we want. But this looks like what I'm after. It looks like, it's definitely, it's got pins on it, so it's through hole. It's got a couple of kind of ears poking out there that solder down onto the board for mechanical strength. This looks like a good part. It's the part I've actually previously chosen. But what becomes more important now is I need to be able to get at the plugins or the libraries for KiCad to be able to actually use this part easily in KiCad. You could draw them yourself. People do that. You could download the data sheet, figure out the measurements and draw it yourself. But it looks like there's models available on SnapEDA. So let's drill into those models and see what we find here. And boom, we're in SnapEDA. I believe I'll need to log in here before I can use it, but let's take a look at what it got us. It got us a symbol and footprint. So here we've got the symbol, and here we've got the footprint. And you can see as we hover over various pins here, it gets highlighted on both sides, so we know the shield connections are these. So this looks good. It's even got a picture here. This is the manufacturer part number. If we go back to Digikey here, we'll see there's a manufacturer's part number and there's a Digikey part number. And if you knew what the part number was in advance, you could search this specific part number in Digikey and find it. You could search their part number and find it, or you could kind of walk through what I just did. But let's go ahead and download the symbol and footprint. I want it for KiCad 4 and later. I'm using KiCad 5. It's going to force me to sign in here. Hopefully I know the password and account. It appears I do. Let's go ahead and download the symbol and footprint again. Maybe. So I'm not sure why. There it is. It just took it a minute before I enabled the button. KiCad version 4 and later. I'm going to go ahead and save that downloaded file. And I'm going to drop it out on my F drive. That's where my KiCad, or my G drive, that's where my KiCad projects are. And I've already created a project here to put this stuff inside of. So I'm going to use this connector example project, and I'm just going to save it here. And I've got that, hopefully, footprint and symbol that I can use. Now I also want a PS2 connector here, and this got a little tricky to find the connector I wanted. I searched for PS2, and I got all kinds of options here that honestly didn't really get me where I wanted to go. I searched for DIN 6. This particular connector is a 6-pin DIN style connector. That didn't seem to really get me what I wanted, and I eventually ended up on circular connectors. Circular. Let's just search connectors. I knew it's connector. I kind of looked through the options here, and there's circular connectors. And if you think about a PS2 keyboard, the female connector, it is circular in shape. So this seems like it might be a good place to go look. So let's dig into circular connectors. Let's see what filters we got. Actually, we can see right here we're really close already. This is the style I want. This right angle mounts to the PC board on the edge. Let's see if we can filter a little bit better. So more filters here, of course. Brings up additional filters. Panel mount, surface mount, through hole, right angle. That seems like it might be a good filter to me. Let's apply those. See what we get to here, and we've got a list of them, and I'm just going to hover over the pictures. What I need is 6 pins for PS2. That's only got 3. That's only got 3. That's got 9 or more. It's not what I'm after. That's got 6. It has potential. That has 3 pins again. That has 4 pins. Looks like 7. That's looking reasonable. No, that's only got 4 pins again. 3 pins. So maybe we need to filter on the number of pins. Let's see if that'll help. So I'm after one that has 6 pins. We can see here that's going to cut it down to 59 remaining. So let's see what that gets us to. See if that gets us a little closer to what we're after here. 6 pins. I think that's one we saw before. That to me looks like more what I had in mind. It's got a metal shield case. You can see that I've actually looked at this part before, and I have. That one might work as well. I think the layout looks correct. That's 6 pins. That's 6 pins. That one's 6 pins. So any one of these might actually work. So let's look at price. $1.94. We start up here, $1.73, $1.94. Not going to spend that much. $1.91. So, the $1.91 is a little bit cheaper. But looking at this is, I don't like the metal front on this. Where you can see the metal. Whereas I like the black plastic front here. It'll look nicer if it's mounted into like a case or something. Just I believe it will. So let's go ahead and drill into this part. We can see again here that we can get the data sheets, but we can see that there's also manufacturing and CAD models. So let's go ahead and drill into the PCB footprint and see what we get. Again, we've got a symbol and we've got a footprint, so those look promising. So I'm going to download for KiCad. I don't remember if it'll force me to log in. I do have an account here as well. It let me download. Let's do a save as. We're in the same folder. So excellent. That all looks good. I may have what I need here. Let's go ahead and look at the zip files now. And I think I'm going to create a folder here to hold this. Not sure what to call it. I'm going to call it, hell, I don't like models. That kind of implies 3D models. Footprints. Let's go ahead and move these both into the footprints. Let's extract them both and see what we've got. I want to extract this one. See what I've got. So let's go ahead and look inside of this one. And we can see we've got a lib file and a KiCad model file or mod file, which is nice. And there's also a how to import.htm here. So let me bring this up and I'll drag this over here on screen. Maybe. So you can see what's in it. And it looks like there's a section for Snap EDA, Eagle, Circuit Studio, KiCad version 4 and later, and I'm running 5.1, and it gives us some instructions here on how to import it. That's really nice. So I'm going to slide this off the edge of the screen over here. Oh, of course it did that. Slide it off the edge of the screen where I can reference it. And let's go look at the, we're actually sitting here in the folder, excuse me, at the other part. And it's got a how to import as well. In both a mod and lib file. That's nice. And actually I've ended up on the same Snap EDA site for these, so I think the instructions are pretty generic. So let me scroll down here. I'll drag this back over. I'll zoom in some here. Makes it a little easier for you to see. There's apparently a video here, which is nice. KiCad 5 and newer, which is I'm running 5 currently. I've not yet upgraded to 5.1. So I'm going to go to the, just what it says, global libraries, browse libraries, click load footprint from library. So it looks pretty straightforward. Let me drag that back out of the way again. I know I'm jumping back and forth here a lot. And let's try these steps. So I'm going to open up KiCad. We've got the project here I pre-created just so I had a project. I'm going to go to Tools, Edit PCB Footprints. This will take a second. It's got a lot of footprints to load up. New library. Import footprint from KiCad file. Well, let's just go straight to that. I'll just kind of guess through here. I've done this a bunch of times, but it's never stuck in my brain how to do this. Projects. We've got connector example. We'll take the USB one first, and let's just go ahead and import the model. And there it is. That looks like what I'm after. The edge of the printed circuit board will be down here. It's got the 2 places to connect grounds. It's got the 4 pins, and something you're going to want to validate as you work through this, that the footprint and the pin numbers are correctly oriented with the when you add a part in the actual spreadsheet or the schematic designer, that those actually line up and make sense. So the question becomes, where did it import this at? Says I can save it. There we go. Okay. So what are my options for saving here? There's a connector IDE or IDC, that's not what I'm after. Phoenix pin headers, pin sockets. Connector USB, that seems like the right place to put it. And I'm going to save it in that connector USB. And we can see what's happened here is, let's see if I can actually get the highlighting to change. I can't. So it's in the connector USBs, and the name on it happens to be that part number from Digikey. It's actually the manufacturer's part number. I've fought with renaming these. You know, part of me likes the fact that that is the you know, manufacturer's part number, but it means you need to kind of keep track of that. And looking in here, we can see, you know, there was mini B's and AB, and I didn't, you know, USB-C. I don't know that I found a USB-A one in here that actually fit my needs, and that's why I had to go search, and I didn't, looking at all these. Actually, that one probably would work. So, but I'm going to go ahead and just leave that there. That looks good to me. Let's go ahead and import footprint from KiCad file. Let's go ahead and import the other one. We've got our footprint file. Yep, and that's the one for the PS2 connector. And I know, actually looking at this, that the numbers here are correct. I've dealt with this connector enough that you know, this matches my expectations for what the pin numbers are, so that's a good sign. Let's go ahead and save it to a library. See if we can find one that makes sense. Now, some people will create a custom library just for their project, and I think that's actually a good practice, and maybe we'll go back and create a custom library and import these into there as well. Connector USB, Wago, wire, AC, DC. I didn't see anything there that looked to me like it made sense. There's not like a connector circular in here. There's a connector DIN, and this is a DIN connector, a DIN style. So that might be a good place to put it. At least I think it's a DIN style. You know, I've got these in here. I can remove them if I want to, and maybe we'll do that. Let's go ahead and create a custom library. So, new library. In my projects, I'm just going to put the library up here in the connector example folder at the root, and I'm going to name it, well, connector example is actually a good name for it. It picked the right name for me because it matches the project name. So let's save that. And I'm going to make this project level. I only want these really to be seen in this project. I could put it global, but that just means other projects, I'd have to search through it. So let's keep it inside of the project. We should now have a connector example folder in here. I don't see it, however. Why don't I see it? Does this need to be refreshed, maybe? Oh, there it is. Let's go ahead and import the two of them again. So let's go ahead and import footprint from a KiCad file. We'll take the PS2 one first. I want to save it. That'll prompt me not for where I want to save it to. What did I do wrong there? Import. There it is. Okay, I think I may just click through too quick. So let's look for my connector example and save it in there. And we'll go ahead and import the footprint for the other part. And it's this guy. And hopefully this will now prompt me for the library, and it did again. Connector example. Did I actually get that saved? I'm not sure. These are the things that just, it's me fumbling around. There it is. Okay, it just got sent to the background. We've got them both in there. It's not waiting for me to save. So let's just go ahead and close out now. And we also need to, worry about the symbols. So edit schematic symbols. We need to let it load these because we also need the symbols. Remember, symbols go in the schematic. So let's create a new library. We're going to call it, here's one of those inconsistencies. Call it connector. Looks like these all have underscores in them, so it probably doesn't allow spaces. Connector example. .lib, it's in the project folder. It's going to be project level again. There's connector example. And I think I can import a symbol directly from here. Import symbol. Again, I need to navigate to drive G, KiCad, projects, connector example. I called it footprints, and that was a bad name. So let's add that. And the little asterisk here means we need to save it. And this is what I was talking about earlier. When we looked at the footprints, it had the pins numbered in the footprint, and it had shield 1 and shield 2. And what's interesting to me is both of these are lumped on top of each other. But these numbers need to match. When you connect a wire to 1 here, it needs to go to the number 1, the correct place on the footprint. So it's a good idea to basically make sure these match up. I think there's probably just 2 symbols here. I'm going to modify it so they're not on top of each other. I think that looks better. It's got all kinds of additional fields here, so I'm going to clean this up a little bit while I'm working in here. I want to field data sheet. I want to move that one as well. It's got a measurement. I want to move that one as well. Looks like a link to where it lives. That's big and ugly. I'm not sure what compliant means. Let's move that as well. And I'm not sure what the for means, but I'm going to leave this like this. At least for now, this text will all be here. So when I save this, we'll see the asterisks. Clear up. So that's been saved. Now let's import the other one. So let's import a symbol again. We want to get into here and grab his lib file. And we've got the symbol here. And this has also got the same thing with the shields, which I find interesting. So I'm not sure why they're lumped on top of each other. That might actually be, a normal practice. I don't know. I'm not going to have enough room here on the device. So while I'm here, I'm just going to redraw this symbol. Let's go ahead and move 3. Again, this is just me being me. I like things the way I like them. We want to go ahead and continue the outline. It's actually drawing with a different line width. I'm just going to go ahead and completely redraw the polygon. So I think that's what I had wrong before. Let me get a polygon that I like. I actually prefer myself to go into the properties Edit rectangle options. And I like to fill with background color. I like it to have that nice yellow inside. Again, that's just me being very old school. Let's go ahead and move this. Move this. Move this. I have no idea what that is. Maybe it's like a version. I actually don't like what I did with the rectangle there. I'm going to redraw it. It wasn't balanced top to bottom. That's better. The space here and here is now the same. Back to its options. Fill with background color. See, now I'm debating with how I like symbols to actually be done. This is fine. Sometimes I like all the grounds. The shields get hooked to grounds. I like those down here. But this is good enough for now. Let's go ahead and save that. Let's go back to the other one. I'm actually going to set its don't think I'm actually getting line options. Yeah, I'm just misreading here. I want to fill it with yellow as well. That didn't, oh, because I'm not actually selecting. Well, I'm just going to do things the way I want to do them. I'm going to go ahead and remove the rectangle. And I'm going to put my own in. I don't know what this 4 is about. I'm on the pointer tool. Why can't I move the 4? There, I was able to grab it. I'm going to go ahead and move this, and I'm going to rotate it, and I'm going to just drop it inside. Even though this never takes. I always end up outside, but I'm going to do that. It's got 2 shields, 4 pins. Let's see how much of this I can actually grab onto and move. I don't know that I want all these fields displayed in the board, but we'll go ahead and let it import. Let's save that. Let's pop out of here. Let's bring up the schematic editor. We want to place a component. And let's just scroll right down to connector example. Let's place another component. The other one that we picked. I can already see I don't like something I did there. That's not yellow filled. So the must be anal in me is going to fix that. Tools, PCB footprints, schematic symbols. Which one was it? This one. Rectangle options, fill with background color. Save. And again, your preferences are going to be different. That should get picked up automatically. Let's play with this a bit. Let's add a ground symbol. Power. Ground is buried down here someplace. And let's hook the shields all to ground. And even though you wouldn't really do this in real life, I'm just going to hook up some pins here. Well, you might actually do this, but I'm just going to go ahead and just connect some pins together. Now I have gone in myself and actually modified footprints to put the pins on the side I want to make the schematic a little simpler to draw. I'm going to call 5 and 6 no connects. Let's go ahead and label everybody. I suspect we'll get a not driven. I'm going to ignore it. I'm going to save the schematic, drawn as is, even though I mean, maybe you do an adapter board for this, but this is ridiculous. I'm just going to actually, let's do this. Let me remove the no connects. Let's just go ahead and say that this pin 5 and 6 are actually ground. Wonder if that'll make the DRC happier. It doesn't, but it doesn't matter. It's saved. It's annotated. We should be able to export a .NET file or a Netlist file. Let's save it. Let's bring up the printed circuit board editor. Let's import the Netlist. I've got to browse to it. It's right here. Oops. I want to just grab one of these. We'll move him over here. We'll move him over here, kind of centered on. We'll just go into edge cuts and actually just put a kind of a board around it. Board is going to run from here. I'm holding down the control key, so it forces me to have straight lines. And I did that wrong. Let's go ahead and delete that line out. Come back to edge cuts. Notice the little circle that pops up there. That says when I start drawing the line, it's going to actually connect to the previous line. These have to be continuous. I need to zoom out here. And I'm holding down the control key again to get things square. We can scroll in here. And you can see this line's following me around. I'm going to hold down control again so the line is locked. And when I get the mouse in the right position here, the mouse pointer, that little white circle appears, and that says it's going to connect that edge cut to the other edge cut I did. And that way, if you don't have all the board outlines connected together, you'll actually get a design rule error. What we should get here is there's a bunch of unconnected items. We'll just work through this board and see what we can make it do. So let's work through. Let's go to the back copper, and we're going to do a copper fill, and I'm going to connect that to ground. And you may have noticed I started the fill outside of the edges of the board. The fill will actually take care of filling. Oops, did that wrong. Let's do the fill again, and I'll say this again, connected to ground, holding down the control key so it forces lines. I can safely go around the outer edge of the board. With the control key down, when I get slid in here, you can see it completes the rectangle. Double click. You can see that even though I did the fill outside of the board, it's still got a proper spacing to the edge of the board for the fill. So that connected up everything but these signals. Let's go ahead and wire up these signals. The next thing we can do here is I'm going to go ahead and do this on the back side of the board. We can still go ahead and route this signal over here. If I hit B, it'll redo the flood fill, and we can see that that trace actually got put in. Go ahead and do this one on the back of the board as well. And I'll do this one. The back of the board as well. And now we've got to get this guy over to here. There's not a great way to do this because we've either got to come between the shield and the pin, It's kind of sad to make this a double-sided board. But you know, this is the pinout we decided on. I really hate, I've got a ground here that's unhappy as well. So we're going to run a double-sided board. So let's go ahead and delete this guy out. And let's reflood fill. And that reflood fill will get this connected back to here. And let's go to the front of the board now and just add our other two traces. So we will route U on the front. And we will route U on the front. Oops, let's actually come up through here. Quit jumping underneath. We can, everybody should be connected now, and they are. Let's go ahead, I'm going to go ahead and just do a flood fill on the front so the manufacturer doesn't waste etchant or on the front of the board. I'm going to add a flood fill here as well. I can conceivably hook it to ground as well, which why not? In this case it's not going to matter. Holding down the control key, click, double click. I've got a fill on the front, so these are well hooked together. We're happy with everything. Let's save it. Let's view it in 3D. Now in this video I'm not going to try to import the 3D models because I haven't ever actually even tried that. But we can see here that we had on the footprint, or the symbol itself, we had S1, S2, and S3, which were tied to ground, which is what these are, S1 and S2. Pin 1 got the square on both sides, and this is 1, 2, don't remember, and 1, 2, 3, 4. That all makes sense. It's a really simple board. But you know, it's a good start. It got me the connectors I wanted. Everything looks like it's probably reasonable pinout-wise. So really nice. So hopefully this little tutorial from digging around on KiCad to actually getting footprints and device symbols in you know, the library makes sense. You can see here that the connector actually sticks out a bit from the board, and that's exactly what I expected, was the shell of the connector slightly off the edge of the board. Those connectors have got me what I wanted, so I'm happy with this. So I guess with that, we'll wrap this quickie video up, and we'll talk soon.